So Benno went looking for a clicker for the slides and came back with 2. I hope that's an omen for the success of the meeting. So good afternoon, everybody. Welcome to DNSOP session 1 at IETF 119. Okay, next. Welcome. You know us. You know Warren. Hi, Warren. The rest of the links here are all the useful things to know about. And we do have a minute taker, Paul Hoffman. Thank you, Paul. Next. Everybody's probably seen the note well. Everybody knows what's in it. Yeah. If you haven't read it, you should. Basically, it means that if you're participating in the IETF, you're following the IETF processes and policies. And the privacy, there's reference to the privacy policy and a bunch of references. Next. You probably also have looked by now at the meeting tips. Please be in Meet Echo, even if you're in the room. Please be prepared to use the microphone cue in Meet Echo, even if you're in the room. That makes it just much easier for the chairs to keep track. And for remote folks, use of a headset. Next. Code of Conduct Guidelines 7154. We know we don't have to spend a lot of time on this either because we know everybody takes it seriously, particularly your chairs. You know, it's some basic principles, but really it's just try to find the best solution for the whole internet. And we work as individuals. Let's remember to be nice to each other. If anybody feels that somebody, there has been an issue with the code of conduct being followed, you can come to any of us. You can come to your chairs or the ombuds team, but please do not hesitate to speak up. Next. So today's agenda, other bashing. As usual, the chair's updates of current work, hackathon updates, a lot of good stuff in the hackathon. The usual current working group business, we go over the current state of the drafts in process in the working group and open issues towards getting those drafts finished and a new draft for consideration. Next. And now I can turn this over to Tim to give us the chair's update.
Cool. Yep. Thank you,
Thanks,
Suzanne.
Tim.
That room looks pretty empty. Wow.
Well, it's a huge room. We were talking about moving the chairs around after we do the meeting and like playing rugby or something. It's huge.
Cool. So let's kick off and go to the next slide. We have some updates on some other working group stuff going on this week. Everybody's probably aware. Who's got this? Who's got the slide clicker?
Yeah, which slide do you want to?
Oh, yep. The delegate meeting is tomorrow. Can you go back one? I had the wrong thing up. Of course, that's the big thing. And tomorrow also is the DNSOP meeting. And multi-queue types is the first thing on the agenda. So people may be interested in that. And then we kick off let's go to the next slide. ADD is Thursday. Nothing stood out on the agenda, but I figured there's usually something going on. And I wanted to give a little update on DPRIVE. The unilateral probing document that Paul and Daniel and Joey worked on is finally getting published at Experimental RFC. I think that's happened in the last couple of weeks. And the working group is basically just going to go off and sort of collect data on that experiment. And then after a year, we're going to regroup. And if there's consensus, we'll have to recharter to put that as a standards track document and then publish it as a standards track. So that's kind of where we're staying. It's going to be fairly quiet, but we're hoping people will start collecting data on any kind of deployments there. We can go to the next slide. And so, pop one more. So this afternoon, actually the hackathon stuff will go first, and then the generalized notify updates from Peter. And Paul's got two documents, 8109 biz, which I'll sort of mention a little bit down the road, and then the 7958 biz. Both coming up. Schumann's going to talk about compact denial of existence, and Willem's going to talk about NS revalidation, which is great because we've got another author for that. And I think with some of the deleg work, this is becoming more interesting. Sort of the next slide. And then at the end, the DNS Greece document that Schumann's going to present. So that looks interesting as well. And then let's do, as we go to the document updates, I've got some notes here. We can sort of cover some stuff. So we hit the next slide. I put the 9499 in there. We have an RFC number, even though the editor hasn't officially pushed it out. So thank you, Mr. Fujiwara-san, for that. And also the caching resolution failures has gotten published. And we have one thing in the editor queue on the next page. We go to the next slide. That is the DNS error reporting. So it's currently sitting, and who knows, some of these that may get moving along. So next slide, there's a couple things going on here. So we have a short pause on the 8109 biz, and Paul's going to talk about it this afternoon. And I tried to sort of summarize some of the feedback. Willem had sent some proposed text to the working group on clarifying section 3.3. It's more editorial and clarifying in nature, not sort of normative. So we're hoping to get some feedback from the working group, but it would not sort of force another working group last call, is our opinion, because it's really more clarifying text. And on the next page, I attempted to summarize Willem's email. It's kind of long. I put the link in here because it's easy to go there and look at that. About the discussion of what's signed and what's not signed when things are validated during the priming queries. So we'll probably push something out, and hopefully we get some folks to sort of look at that and go either way on that. So, and Paul will talk about this here shortly. Okay, so next slide. So the avoid fragmentation, the authors have done a bunch of work based on a lot of the feedback. The chairs have been reviewing it, and we believe it's we probably will have to do like another working group last call because there's been a bunch of changes. But so we'll want to sort of figure out if those are useful, if that's actually going to work. So we'll sync up after this meeting and sort of plan for that. So then we do the next slide. What is the hell's going on? Okay, yeah, the zone version draft. There was a note that Warren's watching it, but as Dwayne pointed out, they published a new version in January, so I have to dig into that and figure out what's going on there, unless Warren remembers. And DNSOP bootstrapping is being written up to finished writing up today. I just want to edit a couple of things, and that write up will go to Warren. Okay, next slide. So we want to stop for a second. Suzanne may want to speak up on this. QD count is 1. We know this is a short document, and everybody agrees to it, but we just need people to sort of step up and say, this is good. Just move it on, kind of thing. Suzanne, do you have any words to say there?
Yeah, only to remind people that for publishing a document, we do need positive support, not just lack of objection. So even if you don't have anything to say except, can we please get this thing out of our lives? Go ahead and ship it. That's actually, that's useful to the chairs. So
yes.
Thanks in advance.
Cool, thank you. As we move on. I was just talking with Shuman about this earlier. The authors feel they've addressed all the outstanding issues, but I'm going through, I've got a number of GitHub issues in there on editorial stuff that I need to go back and double check on. We'll sort of sync that up. I think we're in good shape. Then we'll have to do the working group class call. There's been a lot of good updates to that from Eric and the rest of them. So let's go to the next slide. Service BDane, yes, Service BDane is ready. And we're basically waiting to finish up 8109 biz, not 8109 biz, but the QD count one to kick that off. And so that's kind of our things. CDNS consistency, DNSSEC automation, the authors are sort of getting caught up on their writing, so they should have some new version out pretty soon. But not quite ready for working group last call. Next slide. What do we say here? Yeah, the structured error, the authors really want us to push for working group last call. And while we have implementations, this is such an interesting, sort of a odd case that I guess being cautious is slightly good. I don't know. But and we do feel like things are stuck, but we also feel like we're rate limited by getting consensus feedback on the other documents. And we'd rather, either way, yes or no, let's move them on, sort of thing. We don't want to sort of stack too many things. But we have a pipeline, we can probably push faster. Okay, next slide. I think we're pretty good. Yep, today's agenda, 8009 biz, Paul, and these are going to be short talks, I believe, 7958 biz. DNSSEC validation, that'll be good to get into. Peter's got generalized notify, and so you'll hear about all those here shortly. So next slide. I think we're just hitting all the high points here. And then Johan and Jacob asked, I know this has been presented at DNSOP, and we've had interesting back and forth. They'd like to do a call for adoption. If they really don't think DNSOP's interested, they're, would they be okay with us? Would we be okay with them doing independent stream? And I feel that's open for the working group to sort of pass judgment on.
Yeah, just to clarify, the question for independent stream, and any of the ADs in the room can correct me if I'm wrong, but the working rule we've used before when questions have been whether something belongs in DNSOP or can go to the independent stream editor. If it's something that would interfere with or get to cross purposes with something we're doing in DNSOP, that is something we need to feed back to the IASG because it's relevant to whether it should go through the independent stream. But if there are no objections, if it doesn't seem to tangle up anything we're doing, it can probably go independent. But again, any corrections or elaborations on that, because this doesn't come up very often, but it does come up and we try to get it right. Warren, I'll give you precedence.
Paul
Paul.
Wouters, not the AD for here. So just a clarification that the IEC decides what they want to publish, right? So if you send it there, it might go into a black hole. So that's one. Second is that if there is a working group for a protocol, it is kind of weird for the working group to say, we didn't really have any interest, but why don't you publish it over there? So at least as security ADs, we try to be a little careful about saying like, well, if the working group doesn't want it, you can go publish it in IEC. So I'm a little nervous about this specific way that you're sort of describing that this is an optional way. Like, if there's no interest, why are we doing it?
Or the working group has nothing to add to it. How's that? Like for RPZ, that's what happened, right? There's
But
also
then
some other stuff with RPZ.
I don't know. I would say still run through work group. So there's
Yeah.
a bit of an exception when we're talking about like getting code points, right? Like there's different ways to get code points. Thanks to among others, Paul Hoffman, we fixed the registry so that code points can be gotten without an RFC. So you could actually get like a code point without having an RFC specified in many cases too. So you don't need to go to the IEC for that anymore either. Either though some people like to go to the IEC to get an RFC for something, because then it's easier to get vendors convinced to implement it. But that's kind of not what we should be like putting ourselves into.
Yeah.
Yeah, I think there's sort of some nuance to that. Sorry, Warren Kumari. There can be sort of three outcomes from a working group. Yes, we think that this is our work and we really want to work on it. No, we think this is a bad idea and like, please, it should go away. Or, we kind of think it's okay, but we don't really have the stomach to do it. We don't really wanna. And the ISE is very careful about not stepping on working group toes. So if it's the working group generally, is okay with it, but doesn't think that it's worth their time, it could be reasonable for the ISE. Again, the ISE might also be like, I'm not interested in this, in which case it just dies. Paul is standing behind me with a grumpy look, so.
Paul often stands behind you with a grumpy look, Warren. Nothing new at this moment.
Nothing new.
So let's remember this document is how we did it in .se. It's sort of operational. It's sort of descriptive. It has nothing to do with this working group. It's a valuable document for other registries because, as at least I think, .se does a really darn good job. That's historically exactly the kind of thing that the ISE likes to publish. It's a long-lived document. It says, look how we did things so that other people can copy it. I think it's fine for the working group to say, we're not interested because it's not something that would have been appropriate here. And that, at least in my mind, I certainly can't speak for Elliot. Both Elliot and I attempted to become the ISE. Elliot is the ISE. But had this come to me as the ISE, I would say, great, more like this, please.
No, thank you, Paul. That's actually a good explanation. So I appreciate that. And that's, I feel, the path that this may go down. It is a good document, and we've had presentations, and there's been good feedback in many directions. So thank you.
Yeah, just to close this one out, it sounds like the chairs need to put together, the start of a thread on the mailing list to gather views on this.
Yep.
Does that sound right to you, Tim?
Yes, it does. When
Go
we
ahead.
sync up, we will do that. What else is on this thing? Oh, yeah, some stuff. Stick around for the Friday meeting. Wes has got some updates on these documents that I'm looking forward to, the 8624 biz and the must not use bad crypto drafts. So Friday will be fun. All right. Next slide. And that's, I guess that's it. That's what we're working on. That's what we've got going. We do feel like we can actually, if we can get the speed going, we can get more stuff out because things are sort of waiting, and I don't want to stack everything because then people get grumpy at me. So appreciate that. And I think next, who's doing the hackathon presentations? Oh, I will go. No, it's Willem.
Okay. Willem is already there. Can you do the second half? The DC? Yeah. Okay. Here's the clicker, Willem. If you want to.
After
Yeah.
the effort, we want to.
And
get
there's
that photo.
there's a little surprise. Yeah, the second and third slide are from Stefan, so you have to improvise, or Stefan can present his own slides.
No.
Oh, okay, I didn't. Okay, I didn't. I forgot to update.
Oh,
sorry.
you forgot to upload.
Too many
Oh.
things going on. Yeah.
So what will we do now?
No,
Yeah,
let
okay.
Stefan can present his own slides. Yeah. Okay.
Okay,
Thanks.
the old slides, I guess.
More or less the same.
Yeah.
Okay. So Shimon and myself worked on compact denial of existence. So you know that the idea is to have more compact, less signatures. One of the side effects is that there is no longer an X domain, only no data. And its modification done at the hackathon was only on authoritative name servers, because by default, a resolver has nothing to do. They already handle compact denial of existence. They have nothing to do unless they want to restore the NX domain by using the signaling. So 2 authoritative name servers were hurt during the hackathon. A DNS server written in Python and the drink written in Elixir. Basically, it was very simple. I mean, when you already have dynamic signing in the name server, doing compact denial of existence is simpler than the former technique of RFC 4470 white lies. So also adding the eDNS signaling is quite simple. Compact denial of existence is already implemented even in production, but as far as I know, only in closed software. So it was cool to have something in free software. There have been some discussions about what to do, for instance, when there is a request by a client which is not DNSSEC, which doesn't send the do bit. Should we reply with NX domain or still with no error? That's still something to discuss for the working group. But technically, from an implementation point of view, compact denial of existence works and is very simple.
Yeah, so besides CDE, there was also work done, but most of all, a lot of discussion about DLAC. So as you may know, there's a lot of, there's an initiative to revisit the way delegations are done in DNS. And there will be a Birds of a Feather session about that tomorrow at 9:30 in the morning. And yeah, there was a lot of, but there's also already a draft which does a proposal for a way to do delegation in a new way. So the discussion was led, I would say, mainly by Rolf, Till, and David Blekka. And Manu created a proof of concept in core DNS, the Go DNS library, to set the DLAC flag in DNS key that's used to signal that the delegation could be made of that there is a DLAC record in the parent, so it enables revalidation of following that referral. And I also did a little hack. DLAC introduces a new way for referrals, but the old legacy way can never go. Right, so we will never sunset IPv4 when all is in IPv6 because it's legacy. But DLAC can be the source for legacy delegations. And I created LDNS sign zone version that synthesizes the legacy and SRR set and glue from DLAC and also does the lookups if the DLAC is a alias. And now there was a third project, which I hand over to Johan.
Oops, sorry. So the third DNS project
You
at the
need to
hackathon.
pull the mic up or bend over or something.
Put them in the tall suite.
Yeah,
Yeah.
we
There
keep
you
running
go.
into this problem, right? So the third the third DNS hackathon project was on the topic of automatic child-to-parent synchronization of delegations. And we've been working on this for some time, primarily in the document space, with a number of drafts, and they have been updated and they have been presented, etc. Now we are doing more and more work on the actual implementation side under the idea of something called running code. We are getting closer. We're not really up there with a full implementation yet, but we're aiming for that. We do have two paths to follow. One is the child noticing a child change to the delegation information, sending a generalized notification to the parent. The parent essentially does a CSync or CDS scan, and does the normal thing that the scanner does when it detects a change. And the other path is that the child detects a change and expresses the change in the form of a DNS update, sends the update to the parent, and well, things happen with validation and approval and policy adoption, etc. And it happens. So next slide. Thank you. Next slide. We learned quite a bit of stuff during the hackathon. It's always very, very useful to sit down several people and just bang on bits. The setup is still not working, but never mind. We have learned quite a lot about the amount of analysis that is needed, either in the parent or the child, depending on which path we're using. And we've also learned quite a lot about, let's call it the bootstrapping issue for the unsigned case, because that's one of the things we're playing with here. We're playing both with signed children that can do this in the normal way, signaling to the parent does look up and does DNS validation, etc. But we're also playing with the unsigned child, where the authentication and the security is carried by the 6.0 signature. And in that case, we do have a bootstrapping problem. But we are getting closer to figuring out a mechanism for this to actually also be automated, so to speak. And possibly I will speak on that later on. Thank you.
Okay. Oh. Thank you. Yeah.
A lot of people were present, and this is a number of them.
Yeah. Well, thank you for presenting the results from the hackathon for the DNSOP working group. It's very useful, I think, giving this feedback back to the working group, and so we can make progress in writing up drafts and pushing them forward. Thanks. Thanks a lot. Up next is Peter. Thank you. And Johan, the clicker. Here's the clicker. Here's the clicker, and I will put up your slides in a moment.
Hi, this is Peter Thomason. And I'm going to give an update on the DNS notifications for the problem that Johan just laid out. So here's the quick problem statement. When DNS delegation management needs to be done, and if it should be automated, the way it currently often works is that the child publishes something and the parent has to notice that through some kind of scanning that's slow, and if you do it fast, it's costly. So overall, it's inefficient. And the idea is to reuse the notify mechanism that is well known from replication hinting, essentially, that's shown in the lower part of the diagram. Primary sends notifies to secondaries. And the idea is to reuse that message type and have the signer or the DNS operator send a notify package to the parent. So that's the thing we're dealing with is what's in the orange box on this slide. One could do other things, for example, sending DDNS updates, which is the thing that Johan proposes to do for situations where the zones are not signed. So there is no existing DNS chain of trust for signing things, but you could do 6.0 on of that. So the other draft mentioned on the title slide deals with that part of the problem. And then there's also multi-signer, which we don't treat in this draft. So the news since the last time, the main problem in solving this problem space, the main aspect is actually for the child operator to figure out where to send the notification. Like, how do I reach the registrar, for example? The DNS operator doesn't a priori know who the registrar is. So we fleshed out the mechanism for discovering that notification target. And in doing that, we made 2 minor changes. So there's a record that is published by the parent that conveys information about this notification target. In an earlier incarnation of the draft, it was called, like the record type was called notify. Then we realized, oh, that's kind of ambiguous with a notify message type. So instead, we renamed it to desync for delegation synchronization. This is, you know, the way we thought it should be called. If people have other opinions, that's of course fine. And then there's also a special label that's used, and I will explain in the next slide, but we also renamed, no, actually we are planning to rename that to _desync, but the draft currently says _signal. Then the record type has a field for specifying the notification scheme, for example, whether you do notifies or DNS updates or API calls or whatever. And it's an 8-bit field. And one thing we did in the most recent incarnation of the draft is to reserve some of those schemes for private use. We don't know what that could be good for, but it doesn't hurt. And we also decided to not include multi-signer stuff in this particular draft anymore, because the endpoint discovery requirements between multi-signing operators are different than when you talk to the parent. And it seemed that we would kind of clutter the document if we try to solve it all at once. So the biggest change I said is the endpoint discovery. So here's how it works. Imagine you have an operator for the zone child.parent, and you want to inform the parent of the delegation update that is pending. So the idea is that the DNS operator of the child looks for the endpoint indicator in the parent zone by injecting an _desync label before the parent a part of the zone name. So in this case, it would be child._desync.parent. And under this name, which is under the parent's authority, not the child's, you look for a record of type desync, which is what the parent can publish to convey where they want the notifications or DNS updates or whatever to be sent. So the first field in this record indicates what kind of update you're signaling. The second indicates the method that the parent supports. For example, we receive, we accept, notifies. The third is the port on which you do that. We expect that even if you use an inbound method like notify, it would usually be a separate service, so not port 53. And then there is a target field for putting a host name. So this is how it works, and most of that was already in the last iteration of the draft. What's really new is the thing with the desync and the child in front and this kind of locating things. There is another slide on some properties of this. So it allows the parent to have quite some flexibility in how they want to publish things. So first of all, the parent could synthesize these records if they wanted per child. So for example, if, I don't know, .de decides that they don't want to accept notifies themselves, instead they want the registrars to do it, and they could somehow have like a list of notification endpoints per registrar, they could respond with those dynamically whenever child._desync.parent gets asked for, and then they return the endpoint that is appropriate for the corresponding registrar. And if there's only one endpoint, because the registry does the processing themselves, or they run a forwarder or something, you can put a wildcard there to cover all of that. There is one interesting situation which happens when the delegation is actually not one label under the parent, but several. This happens a lot under .jp, for example. There's cd.ise.mie.jp, which is actually delegated from .jp directly, 3 labels down. And so when you look for this locator desync record, and if you inject the _desync label, you don't know where to inject it, right? The usual assumption would be that you injected one level up from the domain name that you're updating the delegation of, but that might not be the parent. So that's not in the parent's authority. So that's not where the parent can actually publish anything. It would have to go directly in front of the .jp. So the idea is, if we assume the parent is one level up and that returns a negative response, if that didn't work, then the negative response will contain information about who the parent is through the SOA record and the negative response, or even if DNSSIG is used through the signer's name and the signature. So then after that failed, you know who the parent is, and you can make a second attempt and kind of ask directly under the parent with all the child labels prefixed if there are several. And then, so this is how you identify the parent and query for the right record at the right location. Then we thought a third step might be useful for parents who have a policy that they don't want wildcard records in their zone. I don't know personally if that is needed, but other people said that there are such parents. I don't know. And so those parents, instead of publishing a wildcard, they could just publish directly under _desync.jp, just one static record that indicates where they want to process notifiers, for example. And so this could be a third thing that an operator could query at. This is what the draft currently says, and I would like to put it out there for discussion. Also, it's worth noting that in practice, a parent will usually probably get less queries than these three. First of all, because things might succeed after the first one. But even if they don't implement any of this, so you could expect that all three steps are taken. There is negative caching with DNSSEC and all these inferences that resolvers can make. And the expectation is that usually through the lifetime of a TTL, all of this would be with aggressive negative caching, and you wouldn't actually have to do all these queries all the time. The current status is, as Johan said, there is almost running code from the hackathon. We hope to get it running later during this IETF meeting. We also got a DNS directed early review from Patrick. That's much appreciated, lots of feedback. We have to process it. I haven't really had time to digest all of it. And then, as Johan mentioned earlier, there is the other draft that deals with the DDNS-based delegation update for unsigned children and parents. And that draft reuses that discovery mechanism that I just explained. So he made some adjustments to the draft to align it with a new discovery mechanism. And I don't know if there will be a separate presentation of this, but essentially things were kind of adjusted so that they agree. I think that's all I got. And we have a few minutes for questions.
Yeah, certainly. Yeah. So Paul, please go ahead.
Paul Wouters, speaking as individual. I noticed 2 slides back that it said optionally validate. So it basically says like the parent does not have to be DNSSEC signed to still do all of this work. So that comes with 2 worries for me. One, if you're doing things like DNS sync, that doesn't make sense without DNS. So I'm hoping there's some language that says that if you sync records related to DNSSEC, the parent better be DNSSEC signed. Otherwise, these things make no sense, and we wouldn't want those records to be published without signatures. That's one. Second, if it's unsigned and you can send one of these, you spoof one of these records in a caching resolver that's being used, that could be really abused as a targeting attack, right? Like you could try to DDoS a site out of existence by pointing the desync label at it. And then other clients will suddenly try to contact like the endpoint you point to. So again, I would hopefully suggest that you will make DNSSEC mandatory for this part in the parent.
Yes, so I think as far as CSync updates are concerned, that is already mandatory because CSync requires the DNSSEC to be used. So in practice, it would be there. The reason why it says if the parent has DNSSEC is that the DDNS-based update case that Johan has in mind for example, university campus delegations, stuff like that, where they don't have complicated setups and they just provision an update, 6.0 key and that's it. It's not clear whether, yeah, it seems like he will say something, so.
I'm later in the queue, but yes.
Okay. So.
Okay, we'll take it to the list. Thanks.
Okay.
Wes.
It's weird this microphone's so far back in the room. Wes Hardiker, ISI, and the ICANN board, definitely not speaking for the ICANN board. So I've really liked this the instant I first saw it, but I just ran into a problem, right? That authoritative servers that are doing key management are now suddenly supposed to be sending queries, possibly now recursive. I mean, one of your slides had, like 3 or 4 different places that they would have to go look for the desync record, for example. I mean, this is possibly turning code that doesn't currently issue any queries into something that actually has to start issuing queries in order to figure out where to send something, right? Isn't that kind of new?
Yes, but it doesn't have to be the authoritative server. So the DNS operator would have to send it. They probably have multiple instances of their authoritative name server. And once things have replicated everywhere and whatever CDS records are in place everywhere, then it's the time to actually notify the parent. So to me, it seems like you would have a separate service that monitors your replication state. And then once things have converged, you send a notify, but not from your authoritative server, but instead from whatever service.
I'm thinking of
keeps that
something
safe.
like not DNS, the authoritative server that doesn't have, not, unlike bind, which doesn't have sort of both pieces into one, that they end up having to do a much more complex set of key
Yeah.
management operations that involve queries that didn't exist before. You're right, you could do it with a local querying resolver too, but it's a whole nother daemon that you're implementing too. I'm not saying don't do it. I'm just saying I hadn't thought about that.
Yeah, fair enough. So actually not DNS already does queries because they have like the DS wait times and stuff where they see whether the parent already has updated before they continue the automated key roll. But it's sure worth talking to them and see what they say about it.
Jim Reed. Peter, I really like this idea. So more power to you're able to get it pushed forward. But I'm having a flashback to a long time ago with this idea of trying to find the parent, when you're trying to find a parent or a zone cut. And the last time this was discussed, I remember, was quite a long time ago. And the feeling then was that it was bad to rely on getting the SOA record and the negative response to tell you where that zone cut was. I can't remember what the rationale for that was, why it was considered bad, but I wonder if the working group still has that perception today, or if attitudes have changed. Certainly the management of the working group has changed since then.
So I don't know that history, but I would like to learn that history too. One comment I'd like to make is that parents who publish this record probably are not parents who run really, really old software where the SOA record and the negative response isn't reliable. And if they would do that, it would be the time to fix that. So,
okay.
Yeah.
Thank you. Johan?
Yes,
Yep.
another short microphone. So on the topic of the risk of the potential unsigned desync record in a parent being used as after being spoofed as a mechanism for DDoS attacks, etc., it should be pointed out that the entity that looks up the desync is only the child, and it only looks this up when he feels the urge to make a change, which is very, very rare, like whenever you roll your key signing key once a year, if you even roll it, or whenever you change your name server in your NSR set, if you ever do it. So we're talking on per child once a year or less. And yes, I absolutely agree that a desync record could be spoofed, that you send the update or whatever you're sending to the wrong destination. But I have a really hard time to see this becoming a volumetric attack, if I put it that way. The problem I see is rather that you get spoofed and you send it to the wrong destination and the update doesn't happen, which is another type of problem.
Thank you, Peter and Johan. Next up is Paul. Oh, wacht even. There we are. Yeah. Yes, there you are.
Hi there. This is the first of two presentations here. This is on 8109 BIS, which is about priming specifically the root queries. And Peter Koch and Matt Larson are my co-chairs, or my co-authors. So briefly, the status is that we had a working group last call that started in October 10th, finished in January. We published a -03. There were some more issues. We published a -04. Those were both published a month ago. Was submitted to ISG for publication, which means it went into Warren's queue. And then due to I was going to say round table discussion, it was actually a discussion in between 4 round tables with a bunch of people, we asked Warren to pull it back, and I'll explain that in a moment. So the discussion that happened, which started on the list but didn't really go anywhere. Mark Andrews had posted something on the list that didn't get responded to, but Mark was very vehement yesterday in the circle, and a few other people in the circle were like, oh, wait, yeah. Not saying that they necessarily agree because we don't have any wording, but that caused people some concern is that we don't directly deal with the current status of root zone operations. So 8109 bis, at least as it is stated currently in the document, is how to do things. What are the right things to do? What do you expect? And the root zone and the root zone operators are special. Now, all along, we've been saying the root zone is not special. The way you do things is not special. And there's some disagreement about that now. This didn't really come up much during the working group last call, but we wanted to have another opportunity for this to come up. Mark has said he's going to send some wording to the list. I think that would be good. But so right now, even though we finished working group last call, and this isn't just a minor, oh, let's tweak some wording. We had some of that from Willem, which is on this one. But in fact, this, if the working group agrees to this, it would fundamentally change the document. It would fundamentally change the way that the document is presented. So that's going to happen in whatever time it happens. But let me just do the last slide here, which was Willem sent in a message 3 or 4 weeks ago, I think. The document talks about the fact that currently the zone that the names are in, what's the name of the zone? I'm sorry, I'm spacing out because I'm standing up.
For the root servers?
Rootservers.net
Rootservers.net
is not signed. So that's, and it says that in the document. But what Willem wants to say is he wanted extra wording to say, and also notice that the address records are not signed. Now, that ties into, in an operational sense, what Mark brought up. So, and Willem also wanted to say, well, look, unsigned parts can be altered and such like that. Willem sent to the list, there was no response. I didn't know what to do with that. I was going to let Warren say or whatever. That's now been overcome by events because this is now opening up again. So I believe that was my last slide. It is. And so we don't need to have a lot of discussion right now. No, Warren.
Yeah, Warren, please go ahead.
AD always gets to have some discussion. We don't need to have a lot of discussion right now because what I think would be best was actually seeing text on the mailing list for what people want to change. Even if it's not changing the whole thing, if it says, we want these words, if that's going to change words up in the introduction, that's fine. I want to see the technical words. Warren?
Basically, just to say thanks for writing this, and also I'd encourage the working group to actually look at the text when it comes out and reply soon so we can move it along because it's sort of been in limbo for a while.
Great. Thank you. Others? I don't think that was it. So we've got work to do on this.
Thank you.
And by the way, my co-authors don't know about this yet, but that's okay.
Different time zone.
Yeah, exactly right.
Okay. Next up, please.
I'm a QR code. No, I'm not.
There we go. Oh, yeah, talking about QR code. So please use the on-site tool or the full client tool because it's not only for raising your hand for the discussion, but also the blue sheets. Yeah, sorry
Right.
for...
Right, no.
I would like to remind everyone in the room, please use the on-site tool to register because
Right.
it also acts as the blue sheets.
Yep.
Thanks.
Okay, so we're still talking about the root zone, but this is completely orthogonal. This is newish work in the working group. This is how the trust anchor publication happens for the root zone, what many people call the XML file, and associated things. And my co-authors here of Joe, Jakob, and I guess I should know how to pronounce my co-author's first name, but never ask me to pronounce French words. Please go ahead. Oh, please go ahead.
Yeah, there you go.
So we published the 01 a few weeks ago after it came in. There are some significant changes in this. We didn't get any comments on it, but one of the things that is important here, Currently, IANA has many ways to say the same thing, and they're redundant, and some of them are barely used. So we actually removed the certificates and the certificate signing mechanisms while leaving the XML. There may be people who are using those, there may not be, but it's always dangerous to say, I'm going to publish the same information 4 different ways in 4 different formats, and I'm sure that they're all going to be right and up to date. So we removed ones that in fact we believe are not used much, and certainly not used as much as the primary mechanism, which is the XML. We also removed the detached OpenPGP signature, which the folks at IANA have never liked. So that's gone from the draft. And Appendix A had a historical note that was historically wrong. So to be clear, we still have a lot of open issues on this document. Someone said there should be an IANA consideration section that actually says exactly what IANA should do. We're used to IANA consideration section say, go fill in a registry or whatever. This is all about what IANA should do. So it's not going to necessarily repeat everything in the document, but we really should have something that says when IANA makes any changes to the trust anchor, it should do this and this and this and this. So the other thing is, because we took out some things that are not used that heavily, but are sometimes maybe used, that we should actually say explicitly that the result of not doing that is that there's going to be more use of gossip, meaning that people will say to each other, the XML has been updated. Again, there's the chicken and egg problem, or however it's done in other things, but people need to know to get the new root zone. And there are many people have brought up the issue that there isn't a publication mechanism other than word of mouth. And we should be explicit about that. We should be explicit that there is word of mouth. Now, to be clear, IANA normally updates the trust anchor file years ahead of time, years before the new trust anchor is going to be there. So there's plenty of time. However, there is a consideration in case there's an emergency. If they have to do an update, they, like they put out a new trust anchor and it turns out it's already broken or something like that, there will be an emergency update. So that needs to have more description in the document. And then there was also, someone had mentioned, because the trust anchor now is published on, over TLS, just on a normal web page that has TLS, there's sort of the, how do I trust it? Well, I don't, like the chicken and egg. We actually are trusting that information based on the web PKI. And some people in this room like, ew, the web PKI, and that's fine. Trust anchors are the things that you're supposed to think about most when you're thinking about who do I trust. So someone suggested, well, why don't you also at the same time put it in the DNS? Now that's a circular chicken and egg, but for some people, they would find a pre-announcement. So that wouldn't be good in the case of an emergency update, especially if it's like we publish a trust anchor and it's already broken. But it is a reasonable way to do there's going to be a trust anchor in 2 years. So that hasn't been spec'd out. Someone asked if we could do that, and the answer is sure. And that's it for so we're not anywhere close to working group last call. There's certainly more ideas, and we would love more people looking at this with respect to, well, how do I do my own updates? Paul?
Paul Wouters. So am I hearing you correctly that you're saying instead of data origin authenticity, we're relying on transport security?
No, because one of the mechanisms that's still left there is a self-signed a self-signed version of it. So still man in the middleable, but yes, it's not like that we ever, unless you already had some external trust anchor for IANA, it didn't really matter how you were, that the data origin authenticity wouldn't have been there. Does that make sense?
So, okay, so it's signed by a certificate, and that CA certificate is the one that whatever has been used for many years and
No.
still continue to be used? Because I thought you removed that one.
Yep, right. We did. No, I'm saying it's a self-signed message. So all you're getting is at that point, you're sure that you got the message as it was originated, is if there has not been a man in the middle.
It's still kind of transport security, right? At that point.
Yeah,
Like
absolutely.
It's not data authenticity.
How do you do data authenticity if you don't have a trust anchor for the data?
Well, we had one. You removed it.
No, that's not true. The certificates and the certificate signing mechanisms were not certificates that signed the data. They were the same data expressed as a certificate or as a CSR.
I see. Okay.
Right. So the
only-
fact that you're not understanding them is one of the reasons that we actually removed them.
Because I remember doing this when I was packaging up Unbound, where we actually did use the CA certificates to pull down the new files and make sure that they were correct.
Great, but you actually weren't, you didn't actually have any data authentication at that point.
Well, in a way we did, because we downloaded that certificate beforehand, that it came with the package, and then we pulled the file that was signed by those certificates. They weren't recycled every time.
Correct.
And now they are, if I'm understanding.
Well, or that they're not there at all. That is,
I mean, yeah, it's self-signed, so it's like,
exactly
I don't
right.
have it beforehand, right? Like, I don't care who signed it, as long as I know it like 2 years in advance or whatever, what the cert is.
Exactly right.
Okay.
Yep. So if you want them back and you can show a use case why that would be better, great. If your concern is data origin authenticity, oh wow, we're going in and out here. It may actually be, you might like the idea of storing them in the DNS itself. Don't know. I mean, again, please think about it. Please look at it. What we're trying to do is make IANA's job more predictable, not easier. It's fine. They're willing to do as much work as they want, but to make the outcome more predictable. Anyone else? So again, we've got plenty more work to do on this
George is over there.
Oh, I'm sorry, I didn't see him here.
That's because I forgot to put my hand up there. Do you want me to sit down?
No, I'm sorry. They had asked you to do it, and
Yeah,
I did.
I
So I
forgot.
was looking
I
this way into the
apologize.
bright light. Okay.
George Michelson, AP Nick speaking for himself. I've had many conversations over beer about this circular problem of when you start trusting the thing that you have to start trusting, and when you trust someone to tell you to trust the new thing. And I don't think you're going to get closure on this
No, I
because
don't
there
either.
are so many different points of view.
Right.
So you're advocating for a simplification. You're advocating for one path in the many set. And the oppositional view would be sign it with every key known to mankind and womankind on the planet, all CAs in all browser sets all the time, have everybody sign it, and then probabilistically people decide if they trust it or not. And you're trying to find a path somewhere in between, but you're going to, there can only be one.
Not that there can only be one, that there only needs to be one.
And that you're simplifying text to remove burdens from the staff who do this, to get rid of obligatory language that you think is honored in the breach rather than the observance.
Yeah.
So you're aligning text with reality.
Yes.
Okay.
This is DNSOP. You know,
Brave man. I mean, I don't know. I actually used to really dislike the idea that trust was embedded in my browser, and I had to believe the 300 unknown blobs of trust that are given to me axiomatically by the software developer. But at a certain level, these guys could have been lying to me since time immemorial, and I just have no way of knowing.
Right.
And so I am somewhat attracted to many people should sign this data, but the burden on tech staff to create that state is very high.
Yep.
I have no answer. It's just comments around.
Okay. Thank you. And then Liman.
Lars Lehmann, he said most of what I wanted to say. Publishing in many ways is the way to get the trust for the thing. Doesn't have to be necessarily signed by many, but to receive it through multiple channels is a good thing. I want to read it in the newspaper. And also it is being published in the DNS. The DNS key record is there.
Not for future KSKs, which is what a lot of people are relying on this on. They want to load this 6 months, a year ahead of time.
Okay. Right. They would be able to verify it using 5011 when it's eventually published.
But this is a way to, and in fact, that's one of the major reasons why we did this BIS document, was that many people said, we really like the idea of knowing years ahead of time as soon as they've done it. And that's why we reopened.
Okay, yeah, thanks.
And by the way, that would be covered by this last bullet. You could, in something that says, this is not yet your trust anchor, this is a giant text record of the thing that you could have gotten as XML. I mean, XML on a text record, but it still could be that way. And that would be signed by someone at IANA.
Your DNS key to be record.
Yes, exactly right.
Yep.
Okay,
Thanks.
thanks.
Thank you. Thank you all for the feedback. We are running a bit late, 5 minutes, but that's our fault. It's not yours. The chairs use more time at the start. So, but already a heads up for the audience. Okay, yeah, Schumann, please.
All right, good afternoon, folks. I'm Schumann, so I'm going to give an update on the compact denial of existence draft. My collaborator, Christian, I think is remote this time, so hopefully he's online somewhere. And in case folks didn't know, Olafur retired last month, so congratulations to him. And I think we hope that the publication of this document will be our retirement gift to him. So let's not drag this along in perpetuity and try to get this done.
Oh, you used the emotional.
Okay, all right. Can you hear me okay now? All right. Okay. So the revision 3 was pushed out just a few days before the 119 cutoff. And quick summary of the updates. We have updated text in the following sections: responses to explicit queries for annex name, implementation status in the security and IANA consideration sections. And there's also one new section on updates to RFCs, and I'm just going to walk you through those changes. For explicit queries, as we discussed and decided at the last IETF, we now treat annex name as a metatype and return an error if you get an explicit query for them. The proposal is to return format error or response code 1, and that is proposed to match the existing behavior of some common implementations today, like bind and unbound. Although I must mention that this behavior is not documented in any standard that I'm aware of, so I'm actually working on that. You'll hear about that later. And it turns out other implementations do something different. So Power DNS, I think, returns serve fail, for example. And really, we should have some commonality of behavior there. So the bottom line is that authoritative servers should return an error if they see a query for this. But more importantly, resolvers should prevent authority servers from even seeing this message by proactively responding with this error and not attempting to do any kind of iterative resolution by forwarding those queries upstream to the authoritative server hierarchy. All right, so updates to RFCs. There are 2 parts here, and these were identified with the help of the noted RFC archaeologist, Edward Lewis. So thank you for that, Ed. The first part is RFC 4034 has a section that says bits representing pseudotypes must be clear in the NSEC type bitmap. But however, if they're there, you're supposed to ignore them, so it doesn't really matter. But obviously, this spec is doing something in violation of that statement because we are explicitly putting a pseudotype into the NSEC type bitmap to signal non-existence. So the proposed update is the sentence in the red highlight at the bottom there, where we carve out an explicit exception for compact denial of existence. But the moment I wrote this, I thought to myself that should it only be for compact denial of existence, or should there be a more general exception, because it could be the case that some other protocol mechanism is proposed in the future that wants to do the same thing for another reason. So I would be interested in your feedback on that question. But for now, this is the proposed update, which is just a surgical carve out for this draft. The second update is to some text in 4035 that says an NSEC record must not be the only RR set at a given owner name. And it turns out this wasn't true even 1 year after this document was published. As soon as online signing implementations were there, this was not true anymore. And I went back and looked at 4470, and it turns out they do actually mention that this rule should be relaxed, but it is not clear of the scope of relaxation. Is it only for 4470, or does it generally cover any online signing implementation? So we want to make this much more explicit. So we did that in the text that you see in the red. And we also wanted to do it as part of an updates to RFC section, which is the new way that any RFC that updates a previous document is supposed to document things. So I guess you can argue that maybe it's already covered and we don't need this, but let me know if that's the case. Otherwise, this is the proposal to add to this document. The implementation status section has been updated just to document what's deployed in the field today and with what private RR types, and also to document what we expect coming in terms of other implementations. There's a small update to the IANA consideration section, and namely what we do is we now explicitly request the first available number in the meta type range to be allocated for NX name. So that's 128. And it probably doesn't really matter what number we get. It's just, but you know, all things being equal, a smaller packet size is better. So we get a lower number that achieves that because the size of the NSEC record is minimized. So that's a proposal. And there's a few. I think the draft is mostly done, in my opinion. There's a few wrap-up items that came about from discussion just this week at IETF. So should non-DNSSEC queries be required to be responded with NX domain? The draft right now is a little bit loosey-goosey. It's allowed, but it's not prescribed. And I know Tail and other folks have some strong opinions about this, so maybe we should tighten up the language. So I have an open question about should we do that or not. I think Stefan brought up a question about whether the response to an NX name query should also be accompanied by an extended DNS error code. That seems like a perfectly reasonable idea to me. I couldn't find one that is specifically tailored to this type of error, so maybe we need to define a new one. So let me know if you're opposed to that. Otherwise, I'm going to write something. There's also a question about discussing impacts to 8020 and 8198. So 8020 is, to remind folks, NX domain, there's nothing underneath, and 8198 is, what is that, Warren? That's aggressive negative caching, right? So in both of those protocol mechanisms allow you to synthesize NX domain responses, okay, based on NX domain or an NSEC span. And neither of those mechanisms really work very well with these online signing schemes that use epsilon functions or minimally covering NSEC records. So my inclination is just to say that you don't expect them to work very well. There is a way to make 8020 work okay with signaling and more work with resolvers, but that's more complexity in resolvers, so I'm kind of hesitant to propose that, but I could discuss it if there's interest. Otherwise, we'll just say they don't work very well. And the other thing I wanted to talk about was in the early days of this draft, we were thinking of making an early allocation request for the NX name code point, just so the implementations wouldn't have to change things multiple times. And there was pushback at that time because the suggestion was, okay, get the draft much closer to the finish line first before doing that. I think we have reached that point now, so I would like to ask that question again. Can we do that? And with that, I'll stop. So the working group last call is for you guys to determine, but I think it's close to ready, and I'll stop for questions now. That's the last slide.
Okay. Yeah. Thank you. We have time for one or two short questions, comments. No? Okay. Otherwise, bring it to the mailing list, and then we get in contact with you after the IETF for the next steps. Thank you.
Okay, delegation and revalidation. This draft has been going on for a while already, and I very recently joined it. But the motivation for it is to increase the trustworthiness of infrastructure assets. So what is meant by trustworthiness and what is meant by infrastructure assets? Well, if a application needs DNS data, it asks the resolver, and the resolver will fetch the authoritative data that the application needed. And it's good data, and it can be signed with DNSSEC and all's fine. But resolvers themselves also use DNS data. They use DNS data to contact the authoritative name servers that are authoritative for the zones where they fetch the data. Now, this data, when resolvers first bump into it or see it, is non-authoritative and is also never contains DNSSEC signatures, even though the authoritative version of this data may be signed. Trustworthiness. So there's a 27-year-old RFC that talks about a lot of different things. And in a subsection of that RFC is about ranking DNS data. And it defines a list with the most trustworthy DNS data on top of the list and the least on the bottom. And it says that if a resolver encounters a RSET which is more trustworthy than what it had already in cache, then it should replace it with the more trustworthy data. And how trustworthy it is dependent on where it came from. So the motivation for, or how to increase trustworthiness is, why would we do this, is to reduce the risk of cache poisoning and also to reduce the risk of query redirection, improve privacy. There's a paper from Amit Klein, Hajo Schulman, and Michael Weidner that lists 18 different ways to do cache poisoning in the classical way. And 13 ways are or can be mitigated or defended against with revalidation. There's more motivation. So it allows DNSSEC validation of infrastructure assets. This is the prime reason for me to get interested in this. We also have in the draft a way to protect against ghost domains, revoked at the parent, but still resolvable because the client keeps it alive. And zoners are in control of their own NS set, TTL, right? So if they want to make changes, they may want to set the TTL somewhat lower so they can recover more quickly, or they might have longer TTLs for increased security, like root servers.net has much longer TTL than the TTLs for the root servers in the priming query. So quick recap, a resolver gets the non-authoritative NS set from the referral and then sends an explicit query for this NSR set to get the authoritative version. This can be done completely lazily, so it doesn't impact resolver performance. The resolver just does whatever it does before, but it also, when it receives the resolver, spawns an extra query to do the explicit authoritative NS lookup. And so those queries will be spawned without impacting the normal work done for the requested query. And when the responses come back, they will replace the non-authoritative version with the authoritative version. It's optional, but recommended. Here you have the list from RC 2181 again. So what happens? Oh, but I've marked all authoritative data with a value. So most trustworthy has AAA status, and all the non-authoritative data has C status. So this is what is happening with revalidation. The NS set goes from C status to A status, or if we would say that DNS secured data has AAA status, then it can move up to AAA status as well. Yeah, we have also a mechanism to protect against revoked head parent, but still resolvable. The ghost domains is if you still have the child NS set in cache, but the parent TTL has run out, check at the parent, is the delegation still there? If not, wipe the whole cache from that point. This also does not impact normal resolving operations. It's optional, but recommended. Yeah, so what's new since version 5? We now also recommend to validate glue and also to revalidate additional addresses from authoritative NS responses, such as the revalidated NS from a referral response or the addresses from a root priming response. So how does that work? When Resolver receives an authoritative NS RR set, it does explicit queries for the values in the NS set. This can also be done completely lazily and is optional but recommended. And so if in this picture you see, if you already had a status revalidated NSR set or AAA status, the addresses will also get more trustworthiness in the resolves cache. New since version 6, which I posted today, or Shuman did actually, is that we have text to the security and privacy section that mentions that unsigned DNSSEC or address records, all unsigned data can be altered, and by altering the unsigned data in referral responses, queries can be redirected to a rogue name server. And the most important takeaway is, I think, is the higher up in the DNS tree this happens, the higher the impact, because it will enable the attacker to take over the whole DNS space from that point down. So delegation revalidation already provides better protection, even if there's no DNSSEC in the child. But with DNSSEC, it also defends against on-pod attacks. And this is much better than transaction protection with more entropy that is more conventionally used to defend against off-pod attacks. So yeah, let's go back to that a little bit. So sometimes people say, well, you know, it doesn't matter how you get the data. If it's DNSSEC signed, then you can, it has AAA status, so you know it's true. So what else is there? We don't care how you came to that, but we also protect because how higher up in the DNS tree the redirection, query redirection can be done. It will be for the whole tree down. So you also protect against second level domains that are not signed. Right, so I say, don't be a DNSSEC snob and support the unsigned. Alternatives to revalidation, DNS cookies introduce more entropy, but they're only for off-pad attacks. On-pad attacks don't help. Zone MD and serving the local route, that works perfectly. It's all the route priming is basically covered, and also the referrals to the TLD, but the scope is limited, but is where it counts most, so to say, at the up layers. Revalidation and DLAC. DLAC may be or may not be a lot of things, we don't know yet. Tomorrow, 9:30. Parent-child, operator-centric, signed or not. But legacy and SNDS and glue delegations will be needed to for a long time. And delegation revalidation, as described in the draft, works right now. Also for non-DLAC delegations. So I'm reiterating the DNSSEC argument again here. We already have better protection, even if the child does not do DNSSEC. But with DNSSEC, it also defends against on-pad attack. There's a future ID for the 07 version to detect the differences between the child and parent, and then send the EDNS or reports about it. And that's it. So a few minutes left, I think.
Thank you, indeed. So yeah, given time, we allow 2 questions. So I locked the queue already. So please keep it brief so we give some time. And we're running a bit 5 minutes late, so I hope the room understands the situation. Yeah.
Okay, so it is technically possible to have a fully DNSSEC signed server that gives bad answers that then kind of puts the zone in a bad state. I mean, this every time something on the internet will be sort of uncached, so you will have to go down from the 3, and that is where your initial trust comes from. And this revalidation of what the child authorities give might kind of put you in a bad state, even if it's DNSSEC signed, if the child authority is bad. And there has been other stuff proposed. I mean, there was a draft from Fujiwara a couple of years ago that had different ways of doing this. I think we should keep that implementation specific and not have a standard of it for it.
Yeah, I think this is a kind of a straightforward way that makes sense. It was it's mentioned in the cache poisoning papers. They quote earlier versions of this draft as a valid remedy. And also implementations, I understand the argument that the child NS set may be garbage. But it will not be for the lower layers or the upper layers of the DNS tree. So there's also value in doing it only for the root or only for the root and the top level domains. In fact, not resolver does this by default for the root. Unbound also has an option that can do it for everything. Yeah.
And that segues right into my question. So this is basically Unbound's hardened infra records, right?
Hardened referral paths.
Yeah, okay. Yeah. So I think this option appeared like, I don't know, 10 plus years ago.
Yes.
It was enabled in Fedora and RHEL, and it's just never caused any single problem in 10 plus years. So please adopt this.
Okay. Yeah, thank you. Thank you, Willem. And yeah, so Shuan, can I ask you for the last? Yeah, we have time. Yeah, otherwise, yeah, let's have another 10-minute presentation, and I hope the room will stay for another 3 minutes. Yeah, I'm breaking the rules here, but yeah.
Well, I went into relaxation mode because you said you wouldn't have time for me.
Sorry.
All right.
I like to push boundaries here.
I can see that, Benno. All right. Okay. So me again, and here to talk about a new individual draft that Mark Andrews. Where's Mark? Is he here? Okay. Good. All right. Mark Andrews and I produced on greasing protocol extension points in the DNS. Um, so this is the draft, and this isn't really a new idea. So Mark and I think a few other people have been discussing doing things like this in DNS software for many years. But it turns out in the intervening time, other protocol communities have already done this. The basic idea is, and it has a name even, it's called grease or greasing. And the basic idea is this is a technique that exercises the regular use of unallocated protocol code points in DNS queries or queries that you admit, and then observing the results and collecting some telemetry around that. And the goal is to prevent the ossification of current protocol usage patterns by things like middle boxes or even endpoints like deficient DNS actors, authoritative servers or broken proxies, et cetera, et cetera. As I mentioned, it's already used in other protocols, so TLS and QUIC notably. TLS, I think, was the first one that did it. 8701 is the document that describes that. And this document is an application of this technique to the DNS protocol specifically. And I should remind folks that there's another thing you should probably pay attention to. There's this IETF, I think it's a program, not a working group or something. It's called EDM, Evolvability, Deployability, and Maintainability. They met at the last IETF, and they're kind of talking about this general space and how to apply it to. It is an IAB program. I apologize, Wes. Okay, I retract my statement, and I've been corrected by Wes. Okay, so the first question is, what protocol elements in DNS could we grease? So here's a list that we came up with. New DNS header flags, new eDNS header flags, new opcodes, new eDNS options, new resource record types, resource record classes, even transports, although I think some of that is probably covered by the recent thing that dprive put out, right? The opportunistic unilateral thing. But, you know, there's TCP as well, which presumably could be greased. All right, so the next question is how to choose unallocated code points. I think Mark's opinion is that you should just randomly choose from the entire range of unallocated code points, but then you run into problems about what happens when they're actually allocated. We have some ideas in the draft about how to deal with that. You can read about it later because we're running out of time. I'll be quick. But the other option, of course, is to reserve a range from the unallocated code points and reserve that for greasing. Okay, so that's right. There's a slight risk if you do that, that middle boxes or stuff will ossify the greasing range and then don't allow the other things to work. So we'll have to think about whether that's a good idea or bad idea. Here's a table that we put together about those protocol structures, the sizes and the number of values they support, and also the number of values that remain unused. So that's the third column. And then I just want to point out, some people were confused by the numbers here. So I just wanted to explain that there are two different types of fields here. One field is a range of numbers where each number is a code point, and other fields are specifically a set of discrete flags. So that's why the numbers, some of them are 2 to the exponent and some of them are just the length of the field, right? All right, and then there's some additional complexity because some of the protocol elements have a substructure, like the RO type space. It's classified into subranges for data types, queue types, meta types, fibrous. So if you're any entity that's doing greasing may have to understand the structure because different subranges may elicit different response behavior. So you have to, you know, be a little bit sophisticated about how you deal with that. The other question is how often or how frequently to grease queries. And I've just excerpted the text in that document there. Our personal feeling is that most resolvers are very high transaction rate systems. So just doing a small sample of queries and greasing them is probably enough to, over time, get a general picture of brokenness in the ecosystem. We threw out a number 1 in 1,000. Maybe that can be a default, but it probably should be configurable. But that's an open area of discussion. The next question is, how do you detect failures and respond to them? So here again, there could be different types of failures. So for certain types of queries, you may get an error response where you should not have elicited any error. But the converse can also be true, like the eDNS bad version thing is the case, where you expect an error if you emit a packet with an unknown eDNS version number. And if you don't get an error, that's an error, right? There's also failure to respond, which is also an error. There's an entire RFC written about that. Those two guys sitting right there. So if you don't know about that, read that. So that one's a little bit trickier because you need to be able to distinguish that from servers that are actually down. But there are ways to do that. You have to be a little bit tricky about that. So what should be the response to be on failure? So in general, what you could do is just retry the query without the unallocated code point, except for greasing operations that actually generate new queries. Like if you're greasing RR types or RR classes. In that case, I think the only thing you do is you log the error and move on, right? There's nothing to retransmit. Okay, data collection analysis. At the minimum, any server that does greasing should, of course, log the results of the greasing. They could also do proactive alerting to authority service operators if they support newer mechanisms like DNS error reporting. But I think what we would really like to see is some sort of community effort to collect the data and analyze them and get an aggregate picture of the ecosystem as seen by many participating resolvers. And maybe we could do that in conjunction with an organization like DNS.org. And that's it. I'll stop for discussions and feedback. And Mark, I don't know if you want to come up here too.
Thank you, Schumann.
Yep.
Terry.
Terry Manderson, ICANN, speaking as an individual. I really, really like this approach, not because I think everything in the draft is actually going to pass through without a lot of criticism. It's going to be a huge amount, but it's a really great place to start a discussion about the ossification that we have in the DNS right now, and how we can think through those things. So yes, I think this should go forward. I like the work. Thank you.
Okay, great. Thank you, Terry. Yeah, so this is essentially a starting point. We're not saying that everything we're posing will actually work very well or not, right? Okay, thank you. I don't know who's next.
Johan, sorry, Lehman.
Yeah, hi, Lehman from NetNode. I also support this. I think this is a good idea. Isn't this a perfect thing for the Atlas project at Ripens SE to trickle out small queries? You need a large probe system because you need to test.
Sure. Yeah, that's an excellent idea.
Just as an idea to
okay, all right. So Ripe Atlas probes should grease stuff. Yes. I'm on board with that. Thank you.
Peter?
Yeah, Peter Thomason. So I think for TLS greasing, one implication is that when software doesn't support that stuff, it quickly breaks. So people don't actually deploy stuff that doesn't support flexibility in whatever the field's contents are.
Yeah.
Now for DNS, and specifically if you do the sampling, you can always get away with just still being ossified and not supporting that stuff.
Mm-hmm.
And so what you said about getting a picture and then looking at what are bad implementations, that's like measuring, and that's fine. But do you also envision like the other part where you kind of pressurize bad implementations to move along because otherwise they break? Because with the current proposal, they wouldn't really break. So
yeah,
right.
Yeah, so I'll answer that. Yep. Yes, we really do want to pressure implementations to fix stuff, because we've had lots of protocol extensions we've put into the DNS that haven't really worked well because implementations haven't followed the RFCs to date. Like the AD bit, that still doesn't work right. EDNS version, there's servers out there which will echo back an EDNS version 1 query to you. There's servers which echo back EDNS options to you. All these things are things which we need to try and address. There's also going to be out of this tightening potentially of 103.4, 103.5, where things are unclear. When we bumped when we redid EDNS, we really should have bumped the EDNS version then, but things were too broken for it to be much use. And yeah, it's a mess. And yes, from the Flag Day, we see once we start enforcing things, you see very quick compliance with the server compliance once you start enforcing various bits. So, yeah.
Okay,
So
thank you. Schumann, also thank you a lot because we ask you again on the stage and you didn't expect. So thank you for your flexibility. And I also want to thank the room for the extra 5 minutes. The chairs needed 5 more minutes during the DNS or the chair slides opening and discussion. So apologies, it's not the speakers, it's us. Tomorrow, 9:30, Delek, BOF, Friday, 3 o'clock. Am I correct? Yeah, 3 o'clock, DNSOP session 2. Thank you for your cooperation and see you around. Bye-bye.